Am I audible? Hello? Hello?
Yes, yes, audible, sir.
Yeah, okay. So, I have a few questions, extra questions, but if you guys have any doubts, we can maybe start with those. So, like, shall we bring new questions if no one has any doubts about?
We have doubts on variance and covariance problems, sir.
Uh, can you elaborate on the doubt that you have? Like, let's say.
So actually, how to calculate the variance of x? We got the expectation value,
Mm-hmm.
but how to calculate the variance
Okay.
in the
So,
exercise problems we are unable to do.
okay.
And again, the same covariance problems also the same.
Okay. So maybe I will start with the maybe introduction of what variance covariance
Okay,
means
okay.
or something like that. Okay, uh, so let's say you have been given some data, and that data has n number of data points. Let's say x1, x2, x dot 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 till let's say xn. And what you are essentially doing when you say you are calculating an expectation is something like a weighted mean of this. So, uh, weighted mean is the simplest example of a weighted mean is an average. So, let's say you are calculating an average of this data. So, let's say x bar is the average of this entire data, and that is essentially the for a simplest case that is the expected value. We would denote it by e of x. Okay, and the variance is essentially, now let's say you have plotted this all these x values on maybe a, so there is a mean value and you are just putting down these x values where they are. So maybe x1 is here, x2 is here, x3 somewhere here, x4 is this, x5 is this, 6 is this, 7, and so on. So all of these data are just some numbers and they are just spread along this. And let's say the mean value that you are, this x mean that you have calculated is somewhere here. So this particular value, let's say, is the x bar or x mean. So what variance is essentially doing is trying to get an idea of the spread of this entire data. So the way we variance is defined is actually simply this. It's an expected value of x minus x bar squared. So if you want to just calculate the mean of something, so for now this is the simple example where we are considering expectation as a weighted with just equal weightage on all the data points. Okay, so in general that need not be the case, and in your assignment questions that is not the case. So in assignment the weights are different. The weights are basically the probabilities of each of those variables. So this could be, in this case it's just x minus, so x1 minus x bar whole square plus x2 minus x bar whole square, and so on, and you will get xn minus x bar whole square, and that is just the variance of this data basically. When this is and this divided by the number of data points actually. So, and this essentially tells you when you have a weighted kind of when you are taking the weighted of this thing. So here we are assuming an equal weightage on all the data points. That need not always be the case. So you will be weighing, instead of this 1, you will be having the weightage of this data point x1. Okay, so is everything clear till this point, or should I go over any part?
Can you reiterate the weightage part?
What are
The weightage part, can you reiterate?
okay, so weightage, okay, we'll take some dummy data actually. Let's say 1, 2, 3, and some weightage you can choose. That need not be necessarily, okay, I will just make this table. So x and the weightage of x, I'm going to write it as this. So let the weightage of x, let's say, is 4. Weightage of 2, so weightage of 1 is 4. Weightage of 2 is, let's say, 8. Weightage of 3 is, let's say, 2. Okay, so what essentially, so now when you are taking a weighted mean of something, you are essentially looking at something similar to an expectation. So when you are, let's say, the weighted mean of this entire data, so 1, 2 and 3 are your actual data points, but it's 1 is going to be weighted by 4, 2 is going to be weighted by 8, 3 is going to be weighted by 2. Okay, so the weighted mean is essentially going to be 4 times 1 plus 8 times 2 plus 2 times 3 divided by the number of data points, which is 3. Now these numbers that we have as weights, they could also be probabilities, then in which case they will be less than 1, and there will be some small numbers, like let's say 0.1, this could be even be 0.5, and then the last one could be 0.4. Yeah, so essentially the mean is something like a weighted average basically, but weights are basically equal to probabilities. Is that part clear?
Yes, yes.
Yeah, so a variance is now a weightage of x minus x bar squared. The mean was simply expectation of x. Now we are looking at a weightage of this term. So now we have to take for each of the terms, we have to take the mean, from each of the quantities you have to subtract its mean, take square of that, weigh it by the factor that x was weighted. Okay. Okay, let's again take some dummy data. This time maybe let's take the probabilities themselves. So what numbers did I do? 0.1, 0.5, 0.4. And the weightage of x or p of x, whatever you want to call it. And 1, 2, and 3. So what a variance would be is that it's an expectation of this. So which is essentially going to be the probability of x equal to 1 times the value of 1. So what is the mean of this data? What is the expected value of this data actually? So it's just 1 into 0.1 plus 2 into 0.5 plus 3 into 0.4. That becomes so that is 2.3 here. Right? Yeah. So 2.3 whole squared plus 0.5 times 2 minus 2.3 whole square plus 0.4 times 3 minus 2.3 whole square. Is this making sense? What I have written here in the red box. Hello? Hello?
Yes, sir, yes, sir.
Yeah, I mean, someone specifically asked about the expectation, the variance question. So, is it clear to them?
Okay. Yes, sir.
Okay. So, this is the general idea. This is how you are expected to calculate the variance of something. There is another way of calculating the expectation, and it's just a rewriting of this formula above. So you can write the e of x minus x bar whole squared as e of x squared. So you are now taking the expectation of the x squared itself minus e of x whole squared, which in our case this part is actually x bar. So this is x bar whole squared minus e of x squared. So variance can also be written as this. So you can also calculate the variance as this, and the also you can calculate it as shown here. Okay. Now we come to, let's say, the covariance. Covariance is essentially, now you want to calculate this quantity is actually variance, which means how x is actually varying with respect to itself. Okay. And when you have covariance, let's say, so let's say you have a variable x and a variable y. You have some data points x1, x2, x3, and the corresponding data points are y1, y2, y3. Now you want to check if I am changing x, as I change x, what happens to y. If that quantity is of interest to you, then you will use something called covariance, which is just defined as expectation of x minus x bar. So here I am denoting x as the actual x here. Okay, this is the random variable x, and y minus y bar, and x bar and y bar are just the means of those as before. So if you want to calculate the expectation of this entire quantity, there are two ways of doing it. You can either, there is a standard formula for it which goes something like e of xy minus e of x into e of y. So this is one way of doing it, or you can go with the definition of this thing itself, and you can calculate this as, I'll put it in red box. So you have to essentially take the first data point x1 minus the mean of the x's times the weightage of x1 comma y1, because those are the corresponding values for it. So I'm just going to add this up. So weightage of x1 y1, weightage of x2 y2, and this is going to be y2 minus y bar, plus weightage of x3 y3, x3 minus x bar, 3 minus y bar. And that will give you the covariance of this thing. Is that clear? Hello? Hello?
Okay, okay, sir.
Yeah. If anyone has any other doubts.
Sir, there is a lot of background noise, sir.
Yeah, actually I'm in lab, so there is some work going on here. It's kind of, I can't maybe control it, but if you have any, if there was any thing I need to repeat, I can repeat it.
No, sir, everything was clear. Thank you.
Okay.
Let's proceed.
Yeah. If you have any other doubts, we'll go with those. So we covered variance and covariance. If nobody has any doubts, maybe I have some questions also in case if you want new questions.
Yes, sir, please.
New questions.
Yes.
Okay. So maybe I'll share this PDF in case. Actually, the meet is open for everyone. I'm not sure why that would be the case.
Sir, I need your help in MATLAB. Can you?
Yeah, sure. I mean,
Like course is providing items, right?
Yeah.
but I am not able to access.
Uh, okay. How do we resolve that?
Or can I get your mail ID so that I can mail?
Yeah, yeah. I think that would be better. Yeah, I will share my mail ID itself.
Yeah, thank you.
Uh, I've shared some questions also. The Google Drive link is. Can anyone check if it is accessible?
Yes, sir, it is accessible.
Okay. Okay. We are going with the week 2 questions for now.
Sir, I mailed you, uh, but I will later mail you with the screenshots.
Okay. Okay. Sure.
Thank you.
Your name was what? Aditya Singh, right?
Yes, sir, Aditya.
Yeah. Yeah. I have received your mail. Yeah. I'm not sure why this is a bit. Doesn't look much clear in the meet. Okay. Yeah. So this is one question. These two questions actually they are related. So you can attempt this and let me know if you have any doubts. So I will give some 2 more minutes and we'll discuss the answer of the first question. Is that okay? So I'll give some 2 minutes and we'll discuss the answers. Is that okay? Or should we wait for a bit more? If anyone has any doubts still, then maybe they can post in the chat. Would anyone like to share their answer? Or maybe just the approach. Anyone? Am I audible? Hello? Hello? Please explain again the concept for question 1 and how to solve it. The question 1 that I am showing or question 1 from the assignment? I mean the the NPTEL questions. Which you are saying. Okay, thanks. Okay. So essentially what I'm trying to quiz you guys in the question is what is the difference between a disjoint event and independence of events. Is the independence of events clear to you? What does independence of events mean? You are free to open your mic and answer. There is no problem. I mean, it would make the session more interesting if it's interactive. Uh, is the concept of independence of events familiar? Okay. Should I pick a random person where the one event is not dependent on other or there is no condition between them? Yeah, exactly. So what that essentially mathematically translates to is this. Correct. Yeah. 1B. Okay. The answer. Okay, you are getting 0.25. Okay. Maybe would you like to share your approach? Irene? Irene, would you like to share your approach? Your answer is correct. Okay. Should I discuss the answer? Okay, I'll discuss. So yeah, essentially, this is the definition for an independence of events. But what this means that there is no so if an event A occurs, there is no condition that B should occur with this probability or some other probability. That's all that means. Okay. So that is what essentially this equation is also trying to tell you. But a disjoint event is something different. disjoint event means that P of A intersection B is actually 0. So if A is occurring, that means B definitely can't occur. So let's say you are tossing a coin and it comes up heads, you can be sure that tails is not occurring. So in a coin toss, A would be the probability that heads occurs in the toss, and B is the probability that tails occurs in that toss. So they can't happen at the same time. Okay, so that is what disjoint means and what independence means. So you are essentially expected to use these two relations and solve for the questions. So here we have P of A union B, 0.4, B union C, 0.5. P of A union B is essentially P of A plus P of B minus P of A intersection B, and that's what Sandeep just put in the comments. Yeah, that is correct. And then P of B plus P of C is just B intersection C, and you have been told that A and B are independent while B and C are disjoint. So you just plug in the thing here, and you have been also told that P of A is actually given to be 0.2. So you can essentially put this P of A here and here, which now this is going to be resolved into P of A times P of B, because A and B are told to be independent, right? So the first equation essentially becomes 0.4 equals 0.2 plus, this is an unknown right now, P of B, minus 0.2 into P of B. So this equation can give you the P of B. It just becomes 0.25 here. And then you can use that to calculate P of C, which is just, since P of B and C are in disjoint, you can do P of B union C, which is given to be 0.5. And P of B you have just calculated here, so 0.25, and you get P of C equal to 0.25. That's all. I hope this was clear. Anyone has the solution for part 2? Maybe I should bring that question up again. Yeah. Anyone has the solution for question 2? Was the solution for the first part clear to everyone? Okay, Sandeep has got the answer for question 2 also, and I think that is correct. Would you like to share your approach, Sandeep? I mean, you don't need to type it, you can just tell in the mic. That will make the session also more interactive.
Sir, we can write that P of A union B union C is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of A intersection C minus P of B intersection C plus P of A intersection B intersection C.
Yeah, exactly. And that is essentially what this question was testing. And how did you calculate P of A intersection B intersection C?
Sir, since B and C are independent events, so the B intersection C will be 0.
They are disjoint events.
Sorry, sir. Disjoint events,
Yeah,
so
correct.
it will be the value will be 0.
Correct. So this part goes to 0, and this also goes to 0. And P of A intersection C, since you now in the previous question you have C, you have B also, and A was already given. So this is now just a simple substitution problem, and you can just calculate it. Anyone has any doubts with this? Maybe we'll go to the next question. Yeah. Is it clear enough for everyone? The question? Okay, thanks. Maybe all the options are not visible here. Yeah, they are on the next page. Okay, but basically answer is one of these, so I'll just keep this two. Now the probability of you getting the correct answer is 50%. So Sandeep has given the answer. B. Can you explain why do you think that is the answer?
Sir, if the mine is detected, then the probability is given as 0.8.
Uh,
So,
I mean, hey, this is actually a matrix, right? So there is always a second condition to it. So if you are saying mine is detected, uh,
and
so
mine is also present.
mine is present and it is detected by
It
your
is
senses.
detected.
Yeah,
So it is a 0.8,
yeah,
but mine is present and it is not detected.
yeah.
Then it will be the rest case.
Uh, Mine is present and mine is
But
not
it is
detected.
not
It
detected.
is given as y. Yeah,
Yes, yes, sir. So that will be 0.2%.
that will be point two. You are saying, okay. Uh, I have actually given the hint here. So, what do you think is the implication of this column here adding up to 1? Pradeep?
Sorry, sir, I couldn't get the question
Yeah, so
properly.
so essentially I'm asking is what does y equal y being 0.2? So you are getting the 0.2 number based on adding uh, the columns to 1, right? So you want the mine is present, this entire column, should you want them to add up to 1 essentially.
Yes, sir.
So what do you think is the implication of that? What does that mean here? So if you look at what are the entries in this and you add them up to get 1, which is 100% probability. So what you are saying essentially is that if the mine is present and detected, so it is so this could have been any number of entries. Okay, so mine is partially detected, mine is detected with probability to some random things, or wood is detected or anything. The columns could have been any long thing, and you saying that the columns have to add up to 1 in for any random region. What that essentially means is that there is a 100% probability that that region should have a mine for any random region, whether you are testing, whether you have detected it, not detected it, no matter what, the addition is going to 1.
Yes, sir.
So I mean, that doesn't quite make sense, right? For any random region you are testing, there is not guarantee that that region should have a mine.
Sir, we can take a test case that if mine is present and the two subsidiary cases as mine is detected and mine is not detected.
Yeah, but irrespective of, so if I had other columns on that, uh, other entries along the columns, let's say wood is detected, some other, some whatever, I could put anything there, and what you call adding up the columns to 1 would mean that irrespective of what the detection is, it's going up to 1.
Yes, sir.
Yeah,
Yes, sir.
so in reality that won't make really sense, right? I mean,
Yes.
irrespective of the detection being made, the mine is present. That the notion itself is not very sensible.
Sir, then it will be in row wise
Yeah,
direction.
yeah, here it has to be row wise, because if the mine is detected, so mine is detected is actually an event that really did happen. You saw the reading on your sensor that mine
Yes,
is
sir.
detected. Now that could happen in the case that mine was really present or mine was not present. If a mine was not present, it could be anything like rocks or stone or what, wood, something. It could be anything, but mine was not present and your detector still ended up detecting it.
Yes.
So in if you go along rows, adding up to 1 does make sense that you have
Yes.
detected a mine. Yeah, that is the truth.
Thank you, sir.
Yeah, is it clear to everyone, or did I confuse anyone? This what I'm actually showing here is actually something that would help you in the assignments that are posted in the NPTEL. This is actually just a conceptual way I'm just asking you this question. But in the assignments you would be having some numbers given there.
Yes.
You have a question? You're still confused? Please explain again. Oh yeah, okay. So Sanjana is asking to explain again, so I'll just go through this again. So what I'm essentially saying is that uh, uh, here the columns adding up to 1 is not really a sensible thing, because what that would imply is that for any random region you are picking, you are just going to get mine is present has to be true. So column adding up to 1 means that whatever you are saying is a 100% probability event, and in that sense it doesn't really make sense, right? You are, whether your detection, whatever be your detection, you are saying that that has to be, mine has to be present. But if you go along rows and you say that is adding up to 1, that is a event that has to have a probability of 1, because your sensor really showed you a value of 1 of the mine being present there, and that could have happened with the mine actually being present, or it might have not have been present, and it could have been anything. So if it was not a mine, it could have been anything, and it still doesn't uh, change the fact that mine was present, and that thing has to still add up to 1. Okay, got it. Yeah, the answer is A. Correct. So yeah, anyone has any other doubts? Okay, we'll move on to next question. The next few questions are kind of easy, so maybe I'll do the fourth question also. So you are essentially expected to use the answer of the previous question, so maybe note these numbers down, and I think this should be enough time to note the numbers down, and then you are supposed to solve the fourth question. Correct. The answer is 8. Yeah. So would you like to share your approach?
Sir, since the probability of mine not detected but mine is present
Hmm.
is zero point 0.4 and the cost is 20, so the product will be 8.
Yeah, exactly. So anyone has any doubts with about this?
Okay, kindly repeat, sir.
Do you want me to repeat the answer?
Yes, yes.
Okay. So essentially, you are supposed to use the answer of the previous question, which was y was zero point 0.4, x was 0.2, and what a cost essentially refers to is that, so let's say look at the mine not detected. So what when you are, this is actually a very important concept in later on when you are doing classifications. So instead of, let's say, mine or present or mine not present or this kind of detections, if it was some test of some disease. So let's say this is a common example in many books. So let's say you have a test which can detect whether someone has a cancer or not, and then so reporting, let's say the person has a cancer, so mine detected is corresponding to, it has been detected that from the test that the person has cancer, and the cancer is present, which is mine is present, and mine not present is cancer not present, and mine not detected means cancer not detected. So the cost of something, so the disease actually being present and it not being detected is actually going to be high. So that is why this number is 20 here. Whereas mine not present, so the cancer is not present, but the mine is, the test detects that the person has cancer, which will just maybe, so it might cost the person a bit more to get the test redone, but it's not as problematic as the previous case. So my the cancer is present and it is detected that it is not present. So in that case, it's actually a worse scenario, right? So and the zeros along the diagonal are essentially saying that the the mine is present and it is detected. In which case you have no problem. It is not present. It is present and you have detected it, so you are all good. And mine not present and mine not detected is the same thing. So you are happy in that case also. So there was no mine and your sensor said that there is no mine. But what when you calculate cost, what you are essentially checking is that if I'm saying if my sensor output is mine not detected, so how much trouble I am in actually. So it's essentially going to be weighted mean of the two quantities. So it's essentially going to be 20 into the point 0.4, which is the y here, and then 0 into zero point 0.6, which is not contributing to anything. So 20 into zero point 0.4 is 8. That's the answer. Was that clear, or do I need to repeat anything? Was that clear? Who asked that question?
Okay, okay.
Okay, fine. So let's move on. This actually. Okay, maybe we will go with the this combination. Maybe we'll go with the this combination of questions. So yeah. So the description that is given at the top is actually common for all the questions after this. So maybe just note it down. anyone would like to share their solution for 7th question? Okay, anyone has any doubts about the 7th question? Should I discuss the solution or do you need more time?
Yes, sir. Kindly discuss.
Okay. So this question is essentially has given this information. So there is a random variable x and a random variable y, and their joint distribution is a normal distribution with a mean mu x mu y and variance matrix. And you have been told that there is a random variable u which is related to x as follows, and there is a random variable v also which is related to y, cx plus cy plus. Okay. So anyone, you guys know, right, what a Gaussian distribution is, or a normal distribution, or should I cover that first? Actually, it doesn't require you to know that for this specific question. Should I cover that?
Okay, sir.
Okay, I will cover that then. Okay. So this is like extra information here. So like so whenever you are trying to sample some data, let's say your data is going to be some numbers, and I'm going to put so you have a process, let's say, and this process keeps on generating you some data. Okay, and every time you get something out of this process is a number which I'm going to start putting on this number line. Okay, so that is getting a number from this process. This is a stochastic process. Stochastic means it has some probability with which it will generate some numbers. Okay, so there is some distribution behind this process. Distribution is essentially a rule. based on what rule it will generate the numbers that are going to come out. Okay, so let's say the first number that it generated was x1, and I'm putting that number over here. Then it generated x2, which I have put here, and I'll keep on putting whatever it generates on this number line. And in this case, I've just populated the numbers that are coming out. And what is going to happen is that based on the distribution of this process, distribution is essentially the rule. Okay, so rule based on which the probability of getting some number from this distribution is defined. So if this distribution is a Gaussian distribution, then the probability is going to look something like this. Okay, so what this really means is that most of the numbers that are going to come out of this process are going to be coming close to this point, which is going to be the mean of this distribution, and the overall spread of these numbers is going to be the variance of this process, and that is going to be, let's say, sigma. And there is a mathematical formula by which you can calculate. So this distribution has a mathematical formula, and in general it's going to have be something similar to maybe I should rewrite this. So probability of getting any random x from this Gaussian distribution is something like this. Okay, so this is actually the equation of this distribution, and you can later plot this thing, and you can see that it does really come out in this bell shape. So it's actually called a bell shaped distribution also. Okay, and whenever you are going to sample from this distribution, you are going to end up getting numbers which are going to be close to this mean value here. So any sampling is going to look like that, and most of them will be cluttered around this point, around this mean value. And as you go farther away from this mean value, there are going to be fewer and fewer samples. Okay, so that is just a general introduction about what a Gaussian distribution or normal distribution is like. Okay, any doubts till this point? Was that clear? Any doubts? Should I move forward? Clear. Okay, good. Thanks. Thank you for replying, and it really helps if someone responds and lets me know what is going on. So now this is the general definition of a Gaussian distribution, and what we are being told is that x and y are two random variables and whose joint distribution is a Gaussian. So if we were to now look at it, it's going to be a 3D plot. Okay, so I will plot on 2 dimensions what the sampling would look like from this distribution. And so when you say it's a Gaussian distribution, a joint Gaussian distribution, it's going to be something like this. So I want you to note that this is actually the x axis and this is the y axis, let's say, and you have been given this expression, right? X, y are samples from a distribution whose mean is mu x comma mu y. So what that means is that there is a point mu x on x axis and there is a point mu y on y axis, and their intersection, let's say, is somewhere here. This point is going to be the mean of the distribution of this joint distribution. Okay, so any samples that I'm going to get out of this process, just like here, so now there is no a single number is not going to come out of this. Two numbers are going to come out. One will be an x and one will be a y. Okay, so you keep on sampling multiple numbers from this distribution, you will end up with, let's say, something like this. I'm plotting in 2D. Okay, so each of these are samples, and these samples are actually two numbers, and this being a Gaussian distribution means that there is going to be more density of these samples close to this mean point, which was mu x comma mu y, and as you go farther and farther away from this distribution, it's going to be less frequent from farther and farther from this mean point. Okay, so maybe if I try to draw this in 3 dimensions, so x, y, and on z axis I'm now going to plot the probability, so which is p of x comma y, which means jointly getting a number. Okay, so there's this our mean point. Maybe we'll still mark it with pin. This was mu x, this was mu y, and let's do some different. So the probability of getting any point in this xy plane, actually now this is a plane. Okay, you are sampling from a plane, so the probability of getting any point is now going to actually look like a hill. So it's like a 3D okay, maybe it was not that good of a turn. Let's try again. Yeah, so I've just tried to draw two perpendicular lines. So this is actually going to look like a hill. Is everyone getting this? So this is just the probability, and the hilltop is actually exactly coinciding with this mu x comma mu y point, and as you go away from this, the probability is going to reduce. That's why z is reducing below, but at mu x comma mu y it's the highest. Is this clear? Yeah, thank you. Yeah, so now if we try to see what this is, so we have been told that there is a relation, this relation. Okay, so you have been told that there is another random variable which is a function of this x random variable, and there is a random variable v which is a function of y random variable. So, and there we have been told that there is a linear relation, this u is equal to ax plus b, v is equal to cy plus d. So the mean or expected, there are some rules for calculating expectations quickly. So one of those is that expectation of ax plus b is actually equal to a times expectation of x plus b. Okay, this is just a way of quickly calculating the values. So, and you can actually get an idea of why this is happening. So you have now have a point variable u which is related to x only, and you are essentially going to multiply every x number with a and add them to b. Okay, so that will kind of shift this mu x point also. It's just a line. Let's say maybe you should draw in 2D. So this mu x point, there is, imagine there is a line ax plus b. Okay, y is equal to x plus b. This is not this y. Okay, maybe I should not draw it on the same plot. So essentially you are having that mu x point also, and you are going to multiply that one also with a and add a b to it. So you will essentially shift the mean point along x direction to a new point, and all the other points are again going to be sampled around that point, and all of them get through the same transformation, a x plus b. Okay, so that's why you end up with a times mu x plus b, and same thing for y, and you end up with c times mu y plus d. That is for the expectation of u and expectation of v. Okay, is that clear? I think these rules were covered in the notes, if I'm not wrong, classes. Were they covered in the lectures? Hello?
In the first 2 weeks, it is not covered, sir.
What were that? Can you repeat, please?
In the first 2 weeks lectures, it is not covered.
The rules for expectations are not covered.
No, expectations covered in the Gaussian distribution, all these.
Yeah, Gaussian distribution is just a. I mean, you don't really need the Gaussian distribution to solve this question. I was just
Okay.
telling some extra points around it. But these rules were covered, right? The rules for how you can quickly calculate expectation of.
Okay, covered.
Right? Do let me know if anything was not clear. Okay. I hope everything till this point is clear. So we have answered the seventh question. Expectation of for calculating expectation of u and expectation of v. And the next question is about calculation of variance of u and v. So this also comes from directly from the rules. So if you want to calculate, so u was actually ax plus b. So variance of, you are essentially trying to calculate variance of ax plus b, which just becomes a square times variance of x. And when you are calculating variance of v, that becomes, which is cy plus d, it becomes c square times variance of y. And in this matrix, when you see this is actually the variance terms for a normal distribution. So maybe the covariance matrix concept, was it familiar, or should I go through that once? Go through it once. Okay. Thank you. So what we are looking at here is, so what we saw here, this distribution. Now if the covariance matrix was given something like this, one row 1, so row is just some constant, okay, so it could have been any number. For now I am putting this symbol row or whatever. So now if this distribution is having this covariance, what that would mean is that let's say let's, for the sake of it, assume row was 0. So then the distribution is actually supposed to look like a circle, but it will still be with mean. So maybe I should first cover what each of the terms of the covariance matrix mean. So here, this term here actually means variance of x with respect to x itself. So that is what, when you calculated the variance, as I started in the starting of the class, what we calculated, this was that variance of x. This term here is actually the variance of y. Okay, so this I am all relating to this distribution. Okay, and this is true in any joint distribution. Any joint distribution, you are going to have this kind of a covariance matrix, and that essentially, this part of it is essentially telling what is the spread of this data along x-axis and what is the spread of the data along y-axis. Okay, is that part okay? So what these two numbers I have explained, and then you have these two numbers. What this number and this number, they are always going to be same, is going to tell you is that covariance of x comma y. How the variance of x and variance of y are related to each other. So if this distribution has some positive covariance, what that would make the distribution look like is something like this. I will just first put some points on mean, but the distribution is going to be something like that. So are you noticing what is happening here? The distribution, whenever I am increasing x, I am also increasing y. that is essentially what a positive covariance means. Okay, so I'm varying x and increasing it. What is the corresponding way of increasing or decreasing y? If that relation is positive, the y should also decrease, y should also increase. And if I'm decreasing x and y also decreases, then also it is a positive correlation. So them being directly related, that you can x and y being directly related is what a positive correlation would look like, and a negative correlation would like something. I will draw with some other color. It will look something like that. So increasing x is resulting in decrease of y. These are not actually minus. Okay. So increasing x is resulting in decrease of y here. So I am saying that they are both negatively correlated. Okay, is this part clear? And that is what this numbers of this matrix actually denote. So this numbers denotes how x is varying with respect to itself, which means what is the variance of x. This number denotes what is the variance of y, which means how x is varying along this y axis. And these two numbers, the row, how x varies with respect to y and how y varies with respect to x, is going to be the same relation. That's why we have both of these are same, and that's why you have so positive row and this denotes negative row. Okay. Was this part clear? Should I repeat something here? I mean, these concepts will be quite important when you look into something for Bayesian analysis, any type of Bayesian analysis. Should I repeat anything here, or is it clear?
Okay, sir.
Okay, thank you. So then we can actually look at what this is. So till now this okay, I basically covered this. So variance of u then turns out to be this a square times variance of x, which in this question is actually given to be 1, and variance of y is also given to be 1. So you end up getting answer for variance of u is equal to a square times variance of x, which is then equal to a square only, because variance of x is 1 and variance of v is just c square, because it's c square times variance of y, which is, and variance of y is also given to be 1. Okay, and those are the two questions that we have. Yeah. So answer would be A in this question. Any doubts till this point? Maybe can I get some feedback? How is it going? Am I making it too boring? it's just 20 minutes, last 20 minutes, so maybe we'll just go have some feedback. Okay, thanks. So Sanjana says concepts are getting clear. Would others like to add something? Or say, give some suggestions how I can improve, because I'm seeing the attendance got dwindled today a lot from the last time. And you are free to open your mics and say something. It's not a problem. You don't need to restrict to typing here. The pace of lecture is good. I'm able to understand. Okay, thanks. Any suggestions how we can make it, maybe improve it? Can we go through 9th question once? Yeah, okay, sure. So the 9th question is essentially asking us what is the covariance of this joint distribution u comma v. It's a bit more advanced, I would say, at this point. Should I still go through it? I guess no harm in going. Okay, thanks. So till now we were looking at what is the joint of this joint distribution u comma v. So now, since x and y were a part of joint distribution, and there is a random variable u and a random variable v which are related to x and y, they are, so since x and y were a part of joint distribution, there is some correlation or covariance between u comma v also, because u and v are just linear transformations of x and y. So now we are interested in what is the covariance of this u comma v. So we essentially had covariance of x and y given to us, which was rho, but now we are interested in covariance of u comma v. So in that we can so as we saw in the start of the lecture, that covariance of two random variables is essentially given by this expression. Right? So this is u minus the mean of mu into v into mean of mu. And then you can kind of multiply everything inside within this bracket, and you will see uv minus mu u times v mu v times u plus mu u times mu v. Okay, and then now this is another expectation rule, so I will put down here. So expectation of an x plus y is simply equal to expectation of x plus expectation of y. Okay, so that ends up giving us this expression being written as uv minus expectation of mu u into v minus again expectation of mu v into u plus expectation of mu u mu v. Okay, till this point everything clear? I hope it is. So now this expectation of uv is what we are interested in. So this is a product of u and v, and u was actually ax plus b and v was cy plus d. So we can write this here, ax plus b cy plus d plus expectation of, so now mu v in mu u into v. So mu u was actually a constant, right? So there is no, mu u is not a random variable, so you don't need to take a mean with respect to mu u. So there is no, it's just a, mu u is now a constant. So we have that, maybe we can go with explaining it as a part of rules. When you were looking at expectation of ax, that was actually just expectation a times expectation of x. So this scenario is also similar. You essentially end up having mu u times expectation of v. So I will just directly write that instead. Mu u is that constant times expectation of v. Am I missing something here? Oh yeah, minus. This is minus. Okay, and then the other term is mu v times expectation of u, the same way, and then you have expectation of mu u into mu v, which is two constant terms. So expectation of this two constant terms is going to be just the product of those terms. So you end up getting this. And in the previous part of the questions, we have actually calculated mu u, eu, expectation of u, expectation of v, mu u, mu v. All of these quantities we actually already calculated, right? The only thing we need to do is actually expand this term here. And we can expand it like this. Minus all of these terms. And you can notice that expectation of v is also actually mu v, and expectation of u is also actually mu u. You can essentially boil it down and just write minus of 1 mu u mu v. And the first which was actually 7th question if I remember. That question gave you mu u, which we can go and find here. Yeah, expectation of u, which is mu u, was this thing. So I'm just going to write their products down here. A times mu y plus d. Okay, and I also have to expand this term here, which is going to take some space. Now AD, so this also again goes through the same summation rule here. And we end up getting more terms here, and it becomes AD times, now expectation of x was given to be mu x, expectation of y was given to be mu y, and expectation of b into d is again going to be b into d only, and you have to subtract that over here, and you end up cutting a lot of terms actually here. So there'll be a mu x and d here, and b c mu y, which is this term, so this and bd, this bd. Okay, so a lot of terms are going to get, all three terms from here, from this product, are going to get cancelled, which are plus here, minus there. So you end up getting only a into c into mu x into mu y. And then this part still remains. So to calculate this part, you actually need to apply the covariance rule that we saw before. So we said that covariance of x comma y can also be written as, so this had two ways of writing it. It was either e of x minus mu x into y minus mu y, and this could also have been written e of xy minus e of x into e of y, and that can actually give you the e of xy. Okay, so that is what we are going to use now. So but the covariance of x comma y, which was already given to us in this matrix, which is this term here, was actually given to be rho. So we write rho is equal to this minus expectation of x into expectation of y. But what is expectation of x and expectation of y? That is just mu x and mu y, right? So we can write expectation of xy as rho plus mu x mu y. So that is what we are going to substitute over here. And I should get back to green. So AC times rho plus mu x mu y. And this minus AC into mu x into mu y. That ends up giving, so this term gets cancelled. So AC into mu x mu y, which was also present here, AC into mu x mu y. And we end up getting answer AC into rho. So yeah, that is essentially the answer. It was a bit long of a derivation, but was this clear to everyone? Now they are just 3. Do I need to cover anything there, or was it clear? Clear, yeah. Good, thanks. So yeah, the answer is A into C into rho that we have, which was option B. Kind of clear, but it's hard to understand. Okay, yeah, I mean, I will be sharing the notes of this in the same folder that I shared before. Maybe I will put the link to that folder again. So whatever I wrote in this session is also present in this link. So multiple folders. So you just look for something which will be like live notes of week 2 or something like that. Okay. Maybe you can take a look at it again, and then if you still have doubts, maybe you can send me mail. OE23. If you still have any doubts, you can send ask queries on this mail. Okay. And the 10th question is actually just a fact about Gaussian distributions actually. So Gaussian distribution is actually a very special distribution in probability theory. So no matter what you do with it, it always turns out to be, for most operations, it just turns out to be another Gaussian only. So if you do a linear transformation of a Gaussian, it will still end up being a Gaussian, or even for a single variable. Here we are actually looking at a joint variable. So the joint distribution of this u comma v, that also turns out to be a Gaussian, and that is essentially what the question is kind of asking. Yeah. So is the joint distribution of u comma v also Gaussian? Yeah, it also turns out to be a Gaussian, and there is no condition of a C, B, D or rho being anything. It will, since x and y were a Gaussian distribution, u and v, their joint distribution is also a Gaussian. And we have essentially calculated all the parameters required to define that distribution as well. So you have the mean of u and v, you have the variance of u and v, you have the covariance of u and v. So you have all the terms related to it. So yeah, that's it. So yeah, that's the today's session. It's already 8, so maybe we can wrap up. or if you have any doubts, let me know. Okay. Okay. Thank you. Yeah. So we are wrapping up the session. I'll stop the meeting now.